Hello everyone, my name is Peter. Some of you might know me as PMonk from around the Nim community or from my website, peterme.net, where I primarily write about Nim things. I'm here today to talk about Futhark. And Futhark is a project that I released a couple of years ago, and some of you might have already used it. It's basically a tool to allow us to use C libraries automatically in our Nim projects. Many of you probably know that Nim compiles to C, and then that C is then compiled by a C compiler over to the native architecture, the binaries that we use. And this compilation, it's sort of, as you can see here, this is the output of just that for loop. And the Nim or the C code that comes out of the compilation isn't really human readable. It's not something that we're meant to read. If you try to commit something like this into a C project, hopefully the maintainer of that C project will stop you, because this isn't C as you should write C code. But writing C allows us to do something quite nice. So there are a couple of benefits to using C instead of something like LLVM for the output. And one of them is that we can use any C compiler. So as long as your platform has a C compiler, then you can use Nim with that or on that platform. So for example, if we have a tiny microcontroller, but it has a C compiler, the Game Boy Advance, I think it is. Someone wrote a game for that in Nim. So as long as we have a C compiler, we can write Nim projects targeting that C compiler and run Nim pretty much anywhere. Another benefit is, of course, that we can use C libraries. C has a large ecosystem. It was released back in the late 70s. The ANSI standard for C came out sort of late 80s. So it's been around for quite a while, and it has a lot of libraries that you can use. And since Nim compiles to C, we can also use those libraries from Nim. If you have a look in the Nim manual, this is sort of what you're expected to do. So if you have a C file, logic.c in this case, with a function, in our Nim code, we can then define that we import this from C. It takes C integers, which are basically just a compatible integer, compatible with a base platform, in this case, some C target. And we also need to tell Nim, in this case, that we want to compile this logic.c module into our project. And that just tells Nim, or tells the C compiler, where those symbols are coming from. So the first line here, compile logic.c, just tells the compiler that we also need to compile and link this C file into our project. And the second one just tells Nim that we have a function that you can call like this, and just pretend that it's there in C land, and it will be because of the compile statement. If this was a dynamic library or something, we wouldn't need that compile logic.c statement. That would be a linking statement instead. But as you can see, if we have a lot of functions, or if we have a big library with a lot of functions, this can get tedious pretty fast. It's a very manual process writing these statements, and it's not something that's feasible to do for large projects. Actually, the reason why I wrote Futhark was that I was working on a project that had to integrate with a C program that was loading my nim program in as a dynamic library, and I needed to access functions and types from the main program. And I started out trying to use the other tools at the time. Ended up writing these by hand, and then a new version came out. Stuff moved around, changed names, structures had changed. They were adding things into the middle of a struct, so the alignment of everything was off, and I had to do the whole thing over again. So this is not a very sustainable process, writing these by hand. But as I mentioned, there are already, and there have been tools for this for basically forever. C2Nim was written by Andreas in 2014, and it automates this process. You give it a snippet of C code, it spits out a snippet of Nim code. Of course, it's also written by Andreas himself, so it knows a lot about Nim and how Nim interfaces with C, and all of that, sort of how things should be wrapped. But it has a couple of problems. It parses C by itself, so it has a built-in sort of C parser that is written from scratch, and it is it's not great. It doesn't handle all of C. C is a notoriously hard language to parse, but it gives it its best. It also doesn't follow includes. So C2Nim is meant for snippets. You give it a snippet or you give it a small header file, and it will wrap that small header file. But it isn't meant to wrap sort of a full project. So it doesn't follow includes. It doesn't do well with if-defs, stuff like that. Just because if you want to parse if-defs, that's a Turing complete language. You basically need to implement the C preprocessor into your program, which C2Nim just doesn't do. It tries for some parts, but it doesn't do everything. And in my book, one big drawback is that it's intended for post-processing. So the intention with the C2Nim is that you take a C header file or something like that, you give it to C2Nim, you get out a Nim file, and then you modify that Nim file to fit whatever you want your wrapper to do. And the problem with this workflow is that if the upstream header file changes, now you need to remember what you changed in your wrapper. So you sort of need to document all of the changes you've made. You need to remember to do them again if you ever want to wrap the project again. And it's just, you get back a lot of that manual work that we had when we were writing writing these mappings by ourselves. So a couple of years later, someone wrote NimConf. NimConf fixes this last part with sort of scriptable automation. So the idea here is that you write scripts that sort of pre and post processes the inputs and outputs, and that sort of allows you to write more of a recipe on how to wrap the project, and then you just run the recipe whenever the project updates. And maybe you need to tweak some stuff in the recipe, but it's still sort of automatic. Anyone can just download a fresh copy, run your recipe, and it spits out a wrapper. It also uses tree sitter for parsing. The tree sitter is a C, or it's a parsing, but it parses C code, and it was written for the Atom editor. to parse C code for syntax highlighting. So it's a very capable C parser. However, NimDrop still has to parse C semantics. So the tree sitter algorithm parses the C syntax, but NimDrop is still left figuring out stuff like, okay, so this returns this type. What is this type? Where can I find this type? And stuff like that. So it's still missing, or it still has to do a lot of the complicated C stuff. And it doesn't do sort of if-defs, and it still doesn't handle all of that. And as it says in the manual, it may fail on more complex constructs. And that is just, again, it's a C parser meant for syntax highlighting. Doesn't have to be perfect, so it isn't. And it may fail if you have more complicated stuff, especially with lots of macros and things like that. For my project, I spent about a week using C2Nim and another week using NimDrop, trying to get them to work to parse my code base, because I really didn't want to do it by hand. As I said, it's a very tedious process. So I tried to automate the process with these tools, and I just couldn't get either of them to work. I couldn't get them to properly wrap my library. And of course, both of these, they work in a way where if they fail, you fix that failure and then run it again, and you get another fault, you fix that one, and you never know sort of how many of these you have to do. So after a week, am I done tomorrow, or will I have to go another week? And of course, when we're wrapping, when we're doing this automated wrapping, we want things to be as smooth as possible, as automated as possible. And fixing these errors was really tedious. So that's why I wrote Futhark. First version, I spent about a week writing Futhark, and the idea for Futhark came to me when I was watching a SIG video. So SIG is a language that does compile via LLVM, and it has the ability to import C libraries. And I thought to myself, well, I'm saying that Nim is great for C interop because it compiles to Nim. But here we have SIG, which has better support for importing C libraries than we have in Nim. And it doesn't compile via C, it compiles via LLVM. So how does it do that? And I looked into it, and I found out that basically, so Clang, the C compiler, is built on LLVM. In fact, I think LLVM was created for Clang. But what SIG does is that it pulls in libclang, so a library version of Clang, and it just gets that to do the parsing job for it. And that's exactly the same thing that Futhark does. So Futhark, again, a couple of years later, it uses a C compiler for parsing. C compilers are great at parsing C code. So this means that Futhark handles pretty much any C code. As long as you have your imports set up right so that the Clang compiler is able to find all your code, and as long as you have all of your sort of compile time defines and that stuff like that you need to compile a project, it will compile. It will find all of the definitions. It will solve all of the if-defs and macros, and all of that will just be solved by the C compiler because it knows what it's doing. And Futhark basically just takes the output then from the C compiler, and then the only job left is to create the Nim code. And this makes it a very automated process. And it has clean fallbacks. So the C compiler spits out, or the tool I made that interfaces with Clang spits out a definition file. And that definition file is then turned into Nim. And you can then look at that Nim code if something fails or if something isn't right. You can look at that and you can see, well, okay, this is what went wrong. This is sort of, I need an import here. The C compiler will tell you if you're lacking imports. But if you need more functions, you can just figure out where they live, pull in that header file as well. So it's a lot of a cleaner, at least to me, a lot of a cleaner workflow when things fail. And in my experience, it fails way less than C2Nim and NimTrop. As a sort of an in-between thing, it's agnostic to C linking. So it doesn't know, or it doesn't care how you do the compile of the C code. So in the example from the manual, we had the compile this C file and link it. And Futhark doesn't really know anything about how you plan on building this into a C project. You have to figure that out yourself. So you still need to know a bit about the C library that you're using. You need to know a bit about like C linking and how all of that stuff works. But if you're working with C, you kind of have to know a bit about that anyways. And it allows it to be a lot more free in the way that it generates bindings. One minus is that it's still not great on function style macros. So in C, you, for example, you don't have variables with a default value in a function call. You don't have default values. So what you would typically do is you write a function, then you write a function style macro that just takes in some of the arguments and then calls the function with the default arguments, kind of like a template in Nim. And Futhark isn't great with these. I tend to use C2Nim still for wrapping these, and I am thinking of just pulling in C2Nim into Futhark to do these function style macros, because that would basically allow Futhark to do these much better, because these are small snippets of C code, and we can probably get C2Nim to parse those better. It also doesn't parse C++ yet. C2Nim does parse C++. NimTrop has it on the roadmap, but I don't think it handles it yet. And I'm not sure how the last commit to either C2Nim and NimTrop was a year ago. Not sure how much updates they get. NimTrop, I'm not sure how well that is still maintained. But Futhark at least doesn't parse C++, or it parses C++. We're using a C++ compiler, so it parses C++ just fine, but I just haven't written the rules to convert C++ code into Nim code. I just haven't had the time. So if anyone wants to help out with Futhark, that is one big part that is still lacking for a full 1.0 version. To end this talk, we're going to transition this into a live example. I keep talking about how Futhark is so easy and how you can quickly wrap libraries, and I just want to show this off with the time we have left here. So I've chosen here a small library called QR CodeGen. This is just their website in reader mode to get it nice and dark. It consists of just a header file and a C file, and the usage example is really small. However, as I've said many times, you can wrap pretty much anything with Futhark. Here's an example where I've wrapped Map'em is an arbitrary math library. Um, this this builds against a static library that I've pre-built and replaces the internal type, the number type, with an internal type, and then I build the actual Map'em type that I use in my code with automatic destructors and stuff like that, so that it really ties into the Nim ecosystem. So you don't have to do manual memory management of these numbers and all of that. I've also wrapped GDK. So this is my wrapper for GDK3 with WebKit and GDK source view and Pango, and also the full JavaScript engine for WebKit. And I used this to build a prototype of a Markdown editor. And here we can see it's just pretty much tell it which header files, where to find the header files, how to build it, in this case just from pkg config, and then just add some niceties on top of that. But for our example, we are going to use QR code gen. As I said, I've just downloaded the files from the website. I've also gotten a head start and written some code here. It's really easy. Just import Futhark. We tell it how to compile the QR code gen library. In this case, just compile it. And then we tell it that it can find the QR code gen header file in this folder and to import the QR code gen header file. So if we now just compile and run this, we can see I've run this before. So it's using cached output. So Futhark will build, but it will also cache the output so that you don't have to actually run the wrapping process every time you compile. And if we have a look at this code, we can see it's quite a lot of code for such a small library. And we have a lot of these like strange numbers, and we have a lot of when not declared parts here. And this is all part of creating something that always works. When you get Futhark to wrap your library, you will get a file like this. It's not meant to be read. And these numbers, there are type defs in this file that define these as the sort of the correct type. And these are just in case you want to override that type. But this makes it really easy to go in afterwards. You know that the wrapping was successful, and then you can tweak the types afterwards, but not by editing the file, but by overriding stuff in the wrapper code. However, if you want, you can also turn off the declaration guards with the no decl guards flag. If we do this, we see that we get a different cache file. And here we can see that all of these when things are gone, all the numbers are gone. It's just a lot cleaner output if we actually want to look and read the output. However, we can see that QR code gen, along with many other C libraries, will add prefixes. Basically, this is because C doesn't have proper module separation. So in order to avoid collisions, they will add prefixes. But that gets tedious to type. So if we go into our QR code gen, we can add in a simple cleanup procedure. We just register a rename callback. This gets called for every symbol in our wrapper. And it gives us the original name from the C code. It gives us the kind. So is this a structure? Is this an enum? Is this a function? And it also, if it's a member in a structure, so it's a field in a structure, it tells us what this is a part of. And this one is really easy. We just replace QR code gen with an empty string. And if we run this, we can see that we have yet another cache file. And now we can see that all of these QR code gens or that they have disappeared. So now we can start writing the actual usage example. So we have two arrays, QR0 and temp buffer, which are arrays of uint 8s. And then we just call this encode text with these two buffers. So if you have a look at that, I've just loaded that in here. We can see it looks pretty similar in NimLand. If we compile this, we do get an error. Undeclared identifier buffer length max. And this is what I talked about in the presentation. Buffer length max is defined as a function style macro. And Futhark doesn't really like function style macros. In C code, this will just be expanded as text. So it doesn't exist on compile time with type information or anything like that. It's just copy pasted whenever you call this macro. And that makes it hard for Futhark to understand. However, C2Nim is actually pretty good at understanding these small snippets. That's what it's made for. So I've created a command here in Vim that just runs C2Nim on the selected output and writes that out into my buffer. And we can see that it does a good job of wrapping this. Just remove the QR code gen parts and just clean up some of this spacing. We can see that we now have these missing things from the wrapper. This is what I want to add to Futhark in the future. Just pull these parts out of C2Nim and add them in, and Futhark will then automatically generate stuff like this. But for now, we can use C2Nim. We see we got past that error, but now we have a different error, that we have a type definition or a type mismatch. Because Nim is much stricter about types than C. In C, many things just get passed as a pointer. It doesn't really, it's very relaxed on what gets passed around. Here we can see we have an array, and it expects a pointer to an unchecked array, which is how you pass arrays in C. So in our code, we can write a small converter for that. If you have a look at this, we can write this small converter, which basically just takes any array and gives us the pointer to an unchecked array. So this will reduce the type safety a little bit on the Nim side from the type safety that we normally have, but it will increase the interoperability with C. What we can do, if we want, we can go into our wrapper, and we can retype certain parts to be distinct unchecked arrays, and then we can only cast our arrays to those types if we want to get some of that type safety back. But for this, we're just going to stick with the converter. I've also added in this comment here, wrapper end. So everything above this is what is needed at the moment to wrap this library. It's pretty easy. Most of the heavy lifting is done here. This is just for just to make it a bit nicer for us to use. These are just some of the few things that Futhark misses out on, and this is just to make it easier to use from our C code. So now, if we compile and run this, we will see that it compiles and runs fine. We have successfully wrapped the QR code gen library. If we now go in and add in the rest of the usage example, I added a small import here for term style, another library of mine which just adds easier ability to color terminal output. So what we're going to do, we're going to call the get module. So this is just what the usage example says. We get the size of the QR code, the width and height. Then we just add in some padding around the sides. QR codes requires so-called quiet space. So this just adds quiet space above and below. This adds before and after each line. And this right here is the meat of extracting the QR. So of course we could write this to a PNG, or we could do whatever we want with this. But in our case, we're just gonna output black and white colored spaces. So if we now run this, we can see that we have a QR code. So that is basically how easy it is to wrap a C library with Futhark. And that's it for this time. Thank you to the people who have organized this year's NIM conference. Thank you to everyone for listening. These are streaming live on YouTube, so I will be in the comments and answer questions. And of course, if you still have questions, you can always try to find me in the NIM community, or try to reach out to me some other way. That's been my presentation on Futhark. I hope you've enjoyed it, and you'll probably see me some other time. Goodbye.